During your previous math classes, you've learned several basic functions that you should be able to graph fairly easily. Here's the most common basic graphs and each of their domains, ranges, and if they are even or odd. Don't feel like you have to memorize all of the information, but try to be able to quickly come up with these graphs. In calculus, you will be going over more advanced ways of graphing, but you still might have a problem that involves one of these basic graphs, and it would be nice not to have to stress about the basics. Now that you've reviewed the basic graph shapes, let us review how we can use transformations to graph functions which are based on these basic graphs. Here is a table of the basic transformation rules. You can see in the function notation column where the detail that you're going to be changing the function is. So for the first row, we have that if you have your original function and then add k, you get a vertical transition up k units. If you do the same, but with a negative k, you have a vertical translation down k units. If you add a value within the portion of the function which originally only had an x, like if you had an x squared and now it was x plus 2 squared, that would give you a horizontal translation left h units. And then if you had x minus h inside where you originally had x, you would have a horizontal translation right h units. If you multiply the original function by -1, you have a vertical reflection over x-axis. If the original x portion is now negative, you have a horizontal flip reflection over the y-axis. If you multiply the original function by a, you vertically stretch the graph by an absolute value of a when a is bigger than 0. If you have an a that is less than 1, still bigger than 0, you have a vertical compression that shrinks the graph. If you multiply the inside, that x portion, by some variable b, then you have a horizontal compression for x's that are bigger than 0. And if that b is less than 1, then you have a horizontal stretch. Now, when you are not given a function that you can identify the basic graph for, here are some of the things that you can work through to sketch the graph: intercepts, domain, range, positive or negative, degree of zeros, even, odd, quadratics, increasing, decreasing, rationals, asymptote. Now let's talk about the basic trig functions. The main points of a trig graph are the period, phase shift, amplitude, and asymptotes. When you are graphing functions that are transformations of the basic trig functions, these main points are changed. The amplitude of the sine and cosine graphs is the maximum and minimum y value that the graph will reach. The amplitude is given by the number multiplying the outside of the sine or cosine function. The period is the length along x that marks how long it takes for the graph to complete one curve or cycle. Thinking about the unit circle, it takes an angle of 2 pi to go around the whole circle. So, for the basic sine and cosine, the period is 2 pi. For the basic tangent function, the period is pi. Thinking back to traditional transformations, this is like a horizontal stretch or compression. The period of the transformed graph is given by dividing the basic graph's period by the value multiplying the x inside of the trig function. The phase shift moves the function to the right or left like a horizontal shift. You move to the right if the value is subtracted to the x, and you move to the left if the value is added to the x. You need to be careful though, because if there is a change in the period, you need to divide the number adding or subtracting from the x inside of the trig function by the value of the new period. The asymptotes are shifted based on this phase shift. When you are trying to solve trigonometric equations, it might be useful to construct a unit circle with key points labeled to use as a reference. There are many different ways to remember the important angles and their corresponding trig values, but I have found this method of constructing a unit circle to be a helpful method for studying or using as reference. Remember that in higher math we use radians rather than degrees. The whole unit circle is 2 pi radians, so each quarter will be pi halves radians. The angles which divide the 4 quadrants are 0/2 pi, pi halves, pi, 3 pi halves, and back to 2 pi/0. There are 5 key angles in each quadrant. For the first quadrant, there are 0, pi sixths, pi fourths, pi thirds, and pi halves. For the second quadrant, you can find the 5 angles by subtracting the value of each of the important first quadrants from pi. For the third quadrant, you can find the 5 angles by adding the value of each of the important first quadrant angles to pi. For the fourth quadrant, you can find the 5 angles by subtracting the value of each of the important first quadrant angles from 2 pi. To construct the unit circle, you start by filling in the angles. Then work on filling in the values of sine and cosine for each of those angles. You only really need to worry about these values for the first quadrant, since the values are the same for reference angles, only the sign changes. For example, sine of pi sixths is the same as sine of 7 pi sixths, except that the sine of pi sixths is negative. There are more than one way to remember the trig values that go with each angle. Here is one method I find helpful. If you don't like this trick, there are plenty of other tips and tricks available online that you can try. This trick works with the 5 key angles in the first quadrant. Starting from pi halves, working towards 0, write 0, 1, 2, 3, 4 in the x spot, and 4, 3, 2, 1, 0 in the y spot. Then take the square root of each of those numbers. Then divide each one by 2. This gives you the x and y values of the unit circle that correspond to those 5 angles. The x values tell you where the cosine values. The x values tell you the cosine value of that angle, and the y value gives you the sine value of that angle. Take a minute to pause the video now and try constructing the unit circle for yourself. Practicing constructing the unit circle can be one way to memorize the sine and cosine values of the common angles. You will need to be able to quickly find these values as part of longer problems. So you do not want to be stressing over what these values are.